Howdy folks. Today we're going to talk about TypeScript. So TypeScript is a language that was built by Microsoft that is designed to be a strongly typed version of JavaScript. And it can be really helpful to reduce a lot of the common bugs and errors that we run into while writing JavaScript code. Let's get into it. So to start off, let's look at our example here. So I have students coming from a DB.js. I'm getting students by ID with a common reducer. And I'm getting that first student, and if their grade is above 72, we print a nice message. Now, you might have already noticed a couple issues with this code, and that's totally okay. There are a couple issues with this code. I put that on purpose. We're going to take a look at how TypeScript works with that. We'll clear our database really quick. We've got some students in here, IDs, names, emails, a couple other properties. So how do we work with TypeScript? Now, TypeScript, the whole idea behind it is TypeScript is what we call a transpiler. It takes a language, the TypeScript language, and turns it into JavaScript. This is a little different from a compiler, which generally takes a programming language and turns it into machine code, or an interpreter, which takes a programming language and just runs it line by line. So Node.js is an interpreter, whereas the Java compiler is, well, it's called a compiler. Technically, it's actually a bit of a transpiler because of how that's set up, but that's okay. TypeScript looks very similar to JavaScript. In fact, it is kind of what I would say a superset of JavaScript. But it won't run in the browser and it won't run in Node. It's not valid code, which means we have to use a specific compiler, similar to how we would use Babel on our React code. So you can see I've added TypeScript as a dependency in here. And to run TypeScript, you use TSC, which is the TypeScript compiler. Then you give it the file or directory that you want it to run over. So you can see it's also using script.ts, not JS. JS is for JavaScript. TS is for a TypeScript file. So if I run this right now, you see it gives me an error because script.ts does not exist. Well, let's rename our script.js into script.ts. You notice VS Code changed the little icon. VS Code actually has a nice interpreter too that it now recognizes this is a TypeScript file, and so it actually runs TypeScript code on it. And it says, hey, this is all kind of off. Let's fix some of these issues, and it underlines them in red. So if I run that build again, you can see I get a couple of errors, which basically are the same as the errors here. The first one is that require. Cannot find name require. Well, TypeScript doesn't use the require.js syntax. It doesn't recognize it. What it uses is the common JS syntax, which is actually very similar to what we use for our front-end code. So for that, I would actually want to say import students from DB, and this would actually say no default export, and I would actually want this to be DB TS, but we'll get to that in a minute. This similarly, I have that module export, so I would get rid of that, and I've actually kind of already got it here. I want to say export default like that. Okay, that fixes that. Import students. Great. Now students.reduce, this is also an error, and you notice TypeScript is helping us at this point because I made a typo here. I put student 1, and not only did I forget to put it here, this is actually student L, which looks similar to a 1, so you could understand how I'd make that typo. TypeScript picks up on that because it is actually running through and doing static analysis of my JavaScript, and it realizes there's no way this could possibly work. This code is going to throw an error. You can see, cannot find mean student, you mean student 1. Actually, I meant to change that there and that there. Okay, now if I run it, successful. And you notice it has now created script.js. If I look in that, there's a bunch of stuff in here, and this kind of almost looks like how the code would look like if you ran in front-end code through Babel. But you can see here's my require, students by ID, and student one grade, etc. It looks very similar. That is because TypeScript has basically rendered this as JavaScript. So that's the first powerful thing of TypeScript, is that it can help you figure out errors like that. If you try to use something that doesn't exist, it's not going to let you continue. It's going to stop you before it even runs the code. There's a second powerful thing that it can do, and that is the strongly typed syntax of it. So what I'm going to do is I'm going to rename this to TS, and I'm going to import it here. And then when I run my build, I'm actually going to go ahead and put star.ts so it just compiles them both. Okay. Oh, path can only in TS statement allow important TS. Okay. Right, so I think it actually doesn't want the TS in there. Okay, and that built. So now I've got my db.json, which doesn't look that different, and my script. One really powerful thing you can do in TypeScript, though, is the types, right? So if I go over here, you can see I've got my students. What is students? Student, okay, and you can see it's kind of tried to figure something out, but look at that. That's really interesting. Okay, I've got ID, name, email, student, grade, question mark, ID, name, email, student, question mark, grade, question mark, or ID, name, email, student, grade. That's kind of interesting. It looks like it almost is detecting 3 separate types. That's kind of weird. I don't really fully understand. And then object, it's also kind of guessed, right? Here it's saying this could be any. Any type is the default type in TypeScript. It's one that you really don't want to use that much. Any type means we don't know. Could be any type at all, anything. And what it means is there's really no ability for TypeScript to do validation on it. So it's really dangerous, because if you use an any type, TypeScript just kind of throws up its hands and says, well, hopefully you've got this. I don't have enough information to tell you one way or the other. Let's fix that. So what we're going to do is we're actually going to create a type. Okay, so first of all, I'm actually going to put this here, and I'm going to say students equals this, and at the bottom, export default students. There's a reason for that, because I do want to be able to give this a type, and then I'm going to declare a type. And in TypeScript, to do a type, you put type, and you give the type a name, so student, and then like so. And oh, actually, I need to put an equal sign. And now this actually behaves very much like if you were doing, honestly, a SQLized type or an object. So I can put keys, and then I can put what type they are. So this is a number. Name is going to be a string. And you can see tab 9 is actually filling all these out. So, okay, there's that, there's that. Cool. ID, name, email, student, grade. Those are the fields. Now, if I want to actually apply that here, I could put a colon and then student, but not just student, because this is an array of students. So I'll put student and put these little things for the arrays. Oh boy, now we got a bunch of errors, don't we? So now students, you can see it knows student is type of array. We'll fix this in a minute. And this script here, this is type of array. And it knows then that this is a type student. And now you can see some errors starting to show up here. So this is saying, hey, this computed property must be modified time. Oh, maybe it needs to be lowercase. Maybe it needs to be lowercase. No, I'm not sure. Anyway, let's fix this now. So what is it given here? And we look here. Okay, property grade is missing in type. ID, name, email, student, true. But required, that's true. We have declared this as required. We could mark it as non-required by actually putting the question mark. And you can see it actually is perfectly comfortable with that, except for these ones. But I do want the grade to be required. Okay. Well, actually, maybe let's leave it optional, because that's kind of interesting. So that fixes this one, fixes this one. What's wrong with this one? Ah, property student is missing in type, because this one doesn't have that student property. Let's put here false. And you can see how what TypeScript is doing is it's basically forcing me to be explicit about my data. either I need to mark the field as optional with the question mark, or I need to provide it. And that is so that future code can just use that field without worrying about getting an undefined unexpectedly. What's the problem here? String is not assignable type number. The expected type comes from property grade, and grade is supposed to be a number, but I have it as a string. That could have been a really big problem. Imagine if I was trying to compute the average of grades and I tried to concatenate this onto something. If I did it the wrong way, I might actually do string concatenation and then division by string, which would cause a bunch of problems. So that would have been a very subtle little bug that might have been difficult to track down. So we're just going to put that as a number. This looks okay. Let's come back here. Okay. A computed property name must be of type string, number, symbol, or any. I think it's having a problem with, oh, you know what it is? It's saying basically here, it's not really necessarily having a problem with the fact that there's student. It's having a problem with this object. It's saying, look, I want to return this object. But if I look at students by ID, it's like, is this a student? I want this to be a student. It's not actually going to be a student. It's going to be something else. It's going to be an object that contains students as the key. So how do we set that up? Well, what we need to do is we need to declare another type. We could actually do this one of two ways. So what we could actually do is we could just declare it here, and we could just say, okay, this is going to have a key, which is of type number, and that maps to a student. Could not find, oh yeah, because I didn't actually export that type. That's the other thing too, you can export types from here. So what I want to do is let's export. Types actually don't appear in your final JavaScript. So in here, that type is not going to be there because this doesn't make sense as a JavaScript thing, but you can export them so that you can import them in places like this. Student. There we go, we got that. It doesn't like that I call that. Let's see. But that is what I want, right? Index signature must have type string number or a template literal type. What if I call it index? No, it still doesn't like that name. Oh, you know what it is? It's actually right there. Index signature parameter must be of type string number symbol or a template literal. It doesn't like this is capitalized. That's the problem. Okay. Now what is this? Property name must be, and this is the other issue now, a computed property name must be a string, number, symbol, or any. We'll get to that. I can see what's happening there. But basically, this is how I can declare a type like this. It looks a little messy, right? So I could actually declare this as a specific type. Maybe I'd call it type student map, something like that, and use it here. You can commonly do this if you're only going to use this type for one specific purpose. So let's fix this error now. If I come back here, this actually should be a lowercase number. And now that works because now it's saying, okay, yeah, TypeScript does differentiate between capital number and lowercase number, and these actually I could probably make a string as well. Because the other, like the capital number, capital string, capital boolean, those are actually JavaScript classes. And so I was actually telling it this is an object of type number, which, you know, works like this, but not in this other place. What do we get in here? Student 1 grade is possibly undefined. Well, that's really valuable, isn't it? Yeah, what if I don't have a grade? In JavaScript, you might just say, oh, well, the code probably works if I don't have a grade. But that's actually really important because TypeScript requires you to explicitly say what to do if this is undefined. And so that means I actually have to say something like if student1.grade, like that, to just declare that, you know, only run this code if that exists. I could also have something like if not student1.grade exit, something like that. What is this? Yeah, okay, well maybe that's TypeScript isn't going to be super fond of that either. But that is a thing you could also do, is you could do a check like that, and assuming I got that to work, TypeScript is smart enough to realize that the code, maybe I'll just do this, return Yeah, I can't return here either. But it's smart enough to realize if this was working that if it could never get to this code because you've got a guard, it'll handle that properly. But what I'm going to do right now is I'm just going to stay student1.grade and. Now, what this will cause, sometimes this causes you to write additional code, even when you say, look, I know this exists. I know this, there's no possible way, given the code path I called this from, that this variable isn't there. If you get to that point, you may have to change your types, but it's there to help you. And that's why TypeScript takes a little bit longer to write, because you do have to make sure all your types are in order, and it's a little bit harder to write. If you just write some quick structural code that you're doing for a test, it doesn't always work as well in TypeScript because you still have to make sure it's properly typed. Let's look at our last error here. Full name does not exist on type student. That's actually true. If I look at my student type, I don't have the property full name, I have the property name. So this is actually just wrong. I wouldn't have caught that otherwise. Maybe I would have had to write a test or something. So hopefully you can see how TypeScript is able to give you a bunch of different automatic bug fixes that really help point out ways in which your code could be going wrong and help you avoid making a bunch of really common mistakes, honestly, that can cause actually a lot of trouble in a program. There's a bunch of more advanced stuff you can do with TypeScript. I'm particularly fond of its class structure, but we'll get into that in another video. Have a good one, folks, and I'll see you next time.